Hope everyone's here now. Okay, so we're going to get started now. I'm Schuyler St. and today I'm going to talk to you about Intel Galileo, and we're going to get started with it. So what is Intel Galileo? The Intel Galileo is a really cool board that is Arduino compatible. So how many of you here are familiar with Arduino? Okay. It also runs Linux. How many of you here are familiar with Linux? Okay. What about Raspberry Pi? Okay. So about half of you are familiar with Raspberry Pi and Arduino. Okay. So it's sort of like Arduino and Raspberry Pi combined. It runs Linux, so you can do many things you would do in Linux, but it also lets you use existing shields and libraries for Arduino. I actually have a Galileo here I'm going to pass around that you can look at. One of the other cool features on it is it has a mini PCIe slot on the bottom, so you can connect, say, a Wi-Fi card there. And you also can connect something like a webcam or a camera to the USB host slot using something like a USB on-the-go adapter or a micro USB-A to full-size USB-A adapter. As far as hardware goes, there's quite a lot on it. Can everyone see the text there? Good. So a few important things on here is here are the Arduino headers down here and up there. Those are the same headers you would find on an Arduino Uno. Over here is the DC power jack. The one important thing about that is you have to provide 5 volts. If you don't, you can damage your Galileo. It also has a micro SD card slot. So on here you can load a larger Linux distro. We're going to be using that so we can get the Wi-Fi card working with the proper network drivers. Down here you have a reset switch. This will reset the code running on it, the Arduino code and software, but it doesn't reboot the whole Linux thing. Here's the reboot switch. That will actually reboot the whole Galileo. Up there is an Ethernet port. That is one way of connecting it to the internet. You'll also see the I2C address select jumper. For some of the I/O, and it uses an I2C I/O expander. Is that better? Or?
It's better. It's better, yeah.
Okay. And if you have something else on the I2C bus that uses that same address, you can move that jumper to change it. We aren't going to be doing anything with that. On the top there's the 2 USB ports, USB device you use when programming, USB host you use to connect something like a webcam or a keyboard. The SPI flash is where small Linux image is. And lastly, that audio jack there is actually a serial console. And you'd use a cable like this, which goes from the 3.5 millimeter to a DB9, so you can actually get the serial console at the boot prompt and all the things like that. On the bottom of the Galileo, pretty much all there is a mini PCIe connector. You can put a Wi-Fi card in there. Intel recommends you use the Intel Centrino 135N card, I believe it is. You can buy it off Amazon. It's about $15, $20. One of the cool things is because this runs Linux, you can actually set this up as not only to connect to a Wi-Fi access point, but actually have it be its own Wi-Fi access point. There are a few different things you can do when you program this. You can use the existing Arduino environment and program it with the Arduino thing. There are a few extra Arduino commands for the Galileo that we'll get into. You can also do stuff like you would do in Linux. You can have shell scripts. You can use existing Linux utilities. The one caveat with that is that the Linux utilities you use, you have to be able to get them on the Galileo, because currently the software that it has doesn't support like all the packages that are on it. You can't go in the network and get more. But you can go and say with Python, if you get a Python module and you download the compressed file on your computer, if you transfer it over to the Galileo, you can install it that way. And the Linux image that it comes with doesn't have make and GCC on it, but you can rebuild that image to have it, but that's beyond the scope of today's class. So to start out, we're going to go and we're going to program our Galileo to blink the LED. If we look, this should work. Yay, this works. And it's really dim. So if we look here, this is right side up. Here, this LED here, that's the equivalent of the pin 13 LED on an Arduino. Down here, there's an LED for SD card access, and below it, power. Let's see, can you zoom in? Okay, there, you can see that better. So here's the LED for the pin 13. This one is the SD card, and then below it is the power. So to start with our Galileo, what we're going to want to do is we're going to want to download the Arduino IDE. So to do that, open your web browser, your favorite web browser, and you'll want to go to intel.com/support/go/Galileo. And you go there. It will redirect you. This is, can everyone still see that? Good? Okay. You want to scroll down, or actually projector small, it'll be bigger. But on the left, you'll want to click on software downloads, and you'll want to download the appropriate version of the IDE here. This is the same as the Arduino IDE you would use when programming a normal Arduino, but one of the things that's been changed is that it will compile the code for the Galileo, and it also will program it using the Galileo programming thingy. So in this case, you'll download the Mac one. Do you have to unzip it? Yes, I think you do. You'll unzip it and you'll put it in your applications folder. If you also use the Arduino IDE, an easy thing you can do is you can just put it in a separate folder called Galileo, because you can't rename it. It'll give you an error when it compiles. So then when you do Spotlight search, you'll still see it'll show up as Galileo. So what we're going to do is we're going to open that IDE, and I have it opened, and we're going to open the blink example. All of these examples you can get to from the, if you go to, can you see the top? Okay, if you go to, it's sort of hard to see, but open, and then if you go down here are the examples. In this case, we're going to select basics, and then blink. This is it. So how many of you have programmed with Arduino before? Okay, so for those of you that haven't, I'm going to do a quick overview of this. Let's see. So what we're doing is we're starting by creating an integer that is just holding the pin the LED is on. We're doing this so it's good practice, so in the future, if you want to change that pin, you can. Then what we're doing is down here in this function setup, this code in here runs once, and then it goes on to the loop function. All we're doing is we're saying the pin that the LED is on, it's an output. And then if we go down here in the loop, we're turning the LED on, and then we're waiting 1 second. The delay command is in milliseconds, so it's actually going to wait 1 second or 1,000 milliseconds. Then we're going to turn the LED off or low. We're going to wait a second. Then we're going to go back to the beginning and do this over and over again. So to program this on our Galileo, you're going to want to take your 5-volt DC center positive power adapter and plug it into your Galileo. For this you don't need an SD card with Linux on it. I have it in there because it's easy. But so we'll just plug this in, and hold on. Stay put somehow. The cable wants it off the thing, and okay, good enough. So on this, the Galileo, you can see the LED a little more over. You need a bigger desk. Wait, no, that's out. Yeah, that's good. So with this, the camera is slow, but with this you can see the LEDs on it. Now we're going to get our micro USB cable, which I remembered to bring, and we're going to plug it into the USB host or USB device or client connector up here. And we're going to plug that into our computer. And then what we're going to do is we should see, if we go to Tools, Serial Port, you'll see all these. You'll see on a Mac, it'll be Dev TTY or Dev CU. These serial ports are for the Bluetooth. The one you want is dev/cu. whatever. If you unplug it, yeah, it will go away. Oh, sorry. Laptop. So in the Arduino IDE, you'll want to go to Tools Board or Tools Serial Port, and you want to select the /dev/cu. whatever. That will be specific to the board you have. Just unplug it, and then when you plug it back in, you'll see it there. For this, now we're going to click Upload, and it should work. I hope it works. And now it's uploading, and it works. So now, here we see, back to the camera. So now, if we look here, we'll see this LED is blinking. So yay, we have a blinking LED. Maybe lamp. There, that, oh, now you can't really see anything.
There it is. Yeah.
So the blinking light. So now we can also connect up an external LED too. For that, we're going to get our breadboard, which has a bunch of other wires. Zoom out more. I want to try something here. There. That's good. So now, okay, so with this, I have my breadboard here. Can we turn on the lights? That's better. So with this, I'm just going to get an LED and a resistor. LED, resistor, and some jumper wires down here. So what we're going to do is I'll just take these on. So with this, what we're going to do is we're going to connect the LED to this, and we're just going to connect it to pin 13 so we can have a bigger LED blinking. So with this, you could connect, if you had something else you wanted to connect, you could do that too. Right now, we're just going to do this. Let's see, green and blue, or there. So now we have our jumper wires, our LED, and our resistor. We're going to connect on this header here. Let's see, just turning off this. No. So you can't really see it in real life. You can see it, but here, the pins here are labeled. We're going to connect from ground here, which is right after pin 13. That's that one. We're just going to put that here. And then we're going to connect. Is everyone here familiar with how a breadboard works? Okay. So it's all these pins here are connected in rows like this. They aren't connected this way. So I'm going to connect this pin, this jumper wire over here. Of course, it's too short. Now it's long enough. And then we're going to connect, I'm going to spread this out, our resistor across part of it so we don't damage the LED. And then our LED, this needs to be longer. LEDs are polarized, so you'll see there's a long leg and a short leg. The long leg is positive, the short leg is negative. You'll also see that the long leg, so now you can see the LEDs are blinking. So the long leg is positive, the short one's negative. Another thing that you'll also see sometimes is that you'll see a flat side, that's negative. One other thing we'll do before we move on is over here, I need a bigger desk here. We'll just change this to make the LED blink more quickly. So in this case, I'm going to change this to 500, so it will blink for half a second, and then this to 500 too. So now it'll blink every half second. I'm just going to press upload, and it should work. If we go back here, camera, you'll see now it's blinking faster. And also we can make these 2 times be different. So I can make this half a second, and it'll be off for, say, 1.5 seconds. Upload. Now we'll see that it's on for a short time and off for a long time. So now we're sending outputs out. So what else can we do? We can also take in inputs from sensors. In this case, we're going to use an analog sensor, or this potentiometer, which I have here, if I can open the baggy thingy. And the way a potentiometer works is it has three wire leads on it. You can see them. The outer two are across the full span of it, so that's the maximum resistance. The center one is what's called the wiper, and the resistance between the center one and the outer, and say this one and this one, the sum of those resistances is the total resistance, and as you turn the potentiometer, that will change. So what we're going to do is we're going to set this up so we have it has an input. So I'm going to get another jumper wire that's longer. Let's see, like this one should be good. And now I'm going to disconnect this. And what we're going to do is we're going to connect the potentiometer across here. Oh, you can't see that. Out. We're going to connect the potentiometer in the breadboard like this. I hope you can see that. Then we're going to connect the center pin to analog input 0 here. We're going to connect the, let's just say the pin on this side to ground, and then the pin on the other side to power. Ground. So now I'm going to upload a different version of the code. Oh wait, yeah. That, and what this version will do is this will, let's see, basics, read analog voltage, don't save. What this will do is it will read the value. So in the setup thing, you'll see something else, serial.begin. Over the USB port, there's a serial console you have where you can communicate from your computer to the Galileo and vice versa. So all we're doing is we're initializing it at 9,600 bits per second, so 9,600 baud. And then in the loop, we're reading the value of the sensor. It's on the analog input 0 or A0. We're then converting that to a voltage by essentially, it's 10-bit, so there's 1,024, 1,023 steps. 1,023 is the maximum value. And then we're making it, and then we're multiplying it times 5, that's our VN. And now what we're doing here is we're doing the conversion, and we are now going to print that. So if I upload this, it should upload. Now it's done. Can I make this? Okay, so over here we'll see the serial monitor. If I open this, we'll see this is the voltage on this wire here. If I turn this, it should change. So now it's off. Now it's all the way on. I can turn it in the middle. So with this, now we have analog inputs and digital outputs. Let's combine them. So on an LED, to dim an LED, you can't dim it because it's either on or off. But what you can do is you can turn it on and off really quickly so it looks like it's partway in between. So what we're going to do is we're going to use the analog write command. And what analog write will do, we can't make that any smaller, is it will take a pin and it'll turn it on and off really quickly, and it'll vary how long it's on versus how long it's off, and it will then, by changing that, we can control the brightness of the LED. So what we're going to do is on our Galileo, if we look over here, you can see there's a tilde. Let's see if you can see that. Okay. There's a tilde by some pins. That means that they support PWM. So what we're going to do in this case, I'm going to choose pin 9, and I'll just get another Y. PWM means what? It stands for pulse width modulation. What it's essentially is it has a strain of pulses, and by varying how wide each one is, it will. It's essentially what we're doing here is we're connecting our pin goes to an LED. This is a symbol for an LED or light emitting diode through resistor to ground. If we looked at the signal here with PWM, you'll see something like this. And these pulses should all be the same length. This period here, let's say this is 25%. This is 75%. So what happens is it's on for 25% of the time, off for 75% of the time. So the total here is 100%, which is sort of obvious, I guess. But if I were to change this, so we make this where now it's on for 75% of the time and off for 25%, it will appear to be at 75% brightness. So this pulse happens really quickly, so it looks like a blur to the eye, sort of like video. So what we're going to do for this is down here, so first at the top we're going to say put LED, or in, oh sorry, in our code, wrong one, laptop, we're going to create the integer with the pin for LED, so LED pin equals 9. We're then in setup, we're just going to say it's an output, so pin mode, LED pin, output. Then down here what we're going to say is, let's go down here, analog write, LED pin, and for the value, it is 8-bit, so it expects value from 0 to 255. But if you have a 10-bit ADC, we're going to do a similar conversion. What we're going to do is we're going to do, let's see, we'll have to do, so there's actually a function called map. And what map will do, if we do map, you put the original value, so sensor value, the minimum, 0, the maximum, 1024, what we want it to be between, so 0 and 255, and it will scale it for you. That's good. And if you see one of these commands and you forget how you'd use it, you can right-click on it and select Find in Reference, and then it will open up the reference and it will give you this here. It'll show you examples. I'll make this bigger. So in this case, it's map the value, the input low and high value, the output low and high value. Here you can see, like, they sometimes have example code of how to use it here. So this is how I'm using it.
That should be 1023.
Or, yeah, so there are 1024 steps between it, but the maximum value is 1023 because you have 0. But yeah, so now this should work. So I'm going to upload this. And while that uploads, we're going to connect the LED. So we have more jumper wires, if I can get a longer one there. So I'm going to get another connection for ground for the LED. You can see this good. And then we'll put in the resistor. And then the LED. And I'm going to connect this to pin. We used pin 9. Yes. And now you'll see as I turn the knob, the brightness should, yes it does here. The brightness changes. Let's start. So now it's off. As I'm turning the knob, the brightness is getting brighter. The camera doesn't really let you see that. But here, you maybe can see it like this. The brightness changes. Yeah. So now we can do some input and output. We can change the brightness, but this is all stuff we can do on an Arduino. What's cool about the Galileo is, so now that we've done this, we can go and connect our Galileo to the internet and have it do things like that. So for that, this is where having the SD card is really useful, because the SPI flash isn't that big and can't hold that much data. So Instead, I'm using a 4 GB micro SD card. You're also going to want a micro SD to full-size SD adapter so you can get it in your computer. To download what you put on the micro SD card, what you want to do is at the same website you downloaded the IDE from. Down here you'll see this Linux image for SD for Intel Galileo. You want to download that. That will be it's 7-zip, I think they use for it. 7-zip file. On Mac, you can just use something like Kika to extract it. Want to extract it, format your micro SD card as FAT32 because that's what it just works well. And then what you'll want to do is you'll want to copy all those files to the root directory of the SD card. I'm going to turn off the Galileo. You can just unplug it. And if we put the micro SD card in our computer, the files, it doesn't act like the first time you boot it, it won't do anything special and like extract the files. What it will do is, I named it Galileo. These files in here, this is the boot configuration file. These files here have the Linux image and things like that. This directory on the SD card shows up on the Galileo, has /media/real root. So if I just put a new file, find new folder, test folder, and now let's go and put this in our Galileo. If I'm gonna we're gonna connect to our Galileo in a minute, but when we do that, we will see that there actually is that file there. So connecting to your Galileo, there are many different ways to connect to the Linux side. One of them is you can use there's a Linux script. So on this download site, down here they have samples of how it runs Linux commands with the IDE. So if we open those samples, you'll just extract them and put them in your Arduino sketchbook directory. In here, there are a few different ones. One of them is a telnet shell. So if you're on the network, you can do that. Or serial. Actually, wait, no, not that one. You'll want to use the USB shell. And what this will do is it'll let you use your Arduino serial port to connect it over to the Linux console. The one thing you have to be careful of with this is then you have to either undo these changes or something like that to get back to be able to upload code to your Galileo. So what I'm going to do is I'm going to use the serial console cable and a USB to serial adapter cable on the Galileo to get into it. So camera, lamp, you can see that. So you're going to plug in the serial cable into your Galileo. And then we're going to plug in I need to unplug the Galileo. I forgot to plug it in. One other thing is the Galileo, you shouldn't power it from USB because it may draw more power, but you can do that. So actually that's what I did there, and when I unplugged it from USB it turned off. Cable's twisted. Now I'm going to connect my serial cable to my computer. You can also make your own one of these DB9 to 3.5 millimeter cables. It's pretty easy to just solder together. And now if we open, in this case I'm just going to open, where is it? Terminal, and I'm going to ls/dev tty.star. You'll see this serial port, this serial port here in /dev tty star, this is the USB serial adapter. How many of you are familiar with Screen? Okay, so Screen is a utility. It's sort of like a terminal or a serial port program, but it's for the terminal. You could also use something like CoolTerm or TerraTerm, whatever you want. So what I'm going to do is I'm going to open CREN that serial port at 115.200 baud. That's the bit rate it uses. If we open that, just to enter, I can log in. So now I'm on the Galileo. And if I do ifconfig, we'll see there's the WLAN 0. It's not configured. So for this, the Wi-Fi network they have is guest. I'm hoping I can connect to that. So what you're going to do is you're going to do ifconfig WLAN 0. I'm trying to remember. Does anyone here remember how you connect to a unencrypted Wi-Fi from the terminal?
I always use WPA supplicant.
Yeah, I always have used encrypted Wi-Fi. WLAN 0, I think it's SSID. Guest.
Lowercase. Lower guess.
What?
Lowercase guess.
No, it doesn't like SSID. Oh well, Google. And the internet is helpful. Okay, it's ESSID. Bad address. Oh, it's IWconfig. That's what I was forgetting. So IWconfig is the configuration for the wireless and all that. IFconfig is the configuration for the network. So now if I do IFconfig, it should have an IP address on WLAN 0. I think it does.
Yes.
Oh, it'd be nice if it had an IPv4 address. I don't see, let's see, WLAN 0. It's really hard with the text.
Can you just use the Galileo name?
Yeah, I don't think it's configured that way. Yeah, so you can, typically I'd SSH into this. Because this isn't working, I'm just gonna make sure this has.
For IPv4, don't you have to use like a DHCP client, like DHC client or DH client?
Yes.
Reach out to the DHCP server.
Oh, I know. Oh, okay, yeah, DH client. Oh. This isn't working. So another way you can connect to Wi-Fi is you can use the Wi-Fi library, which will do essentially everything you would do from the terminal, but it does it for you, so you don't need to remember it. So if we open that library and we go to Wi-Fi, let's see, connect with no encryption. Down here I just put in guest. This should work. Oh, don't save that. And now the problem is, or I'll unplug that. Now if I plug in my Galileo to upload code to it, see, this one, upload, please work, please work. So Control-Shift-M also opens a serial monitor. It should, let's see, it's not ready. So it's attempting to connect. In the code to connect, because of the way it works and it calls the commands from the terminal like ifconfig and that, when you connect to a network that has a space in the SSID, there's a bug in the library where it doesn't put quotes around it, so it might not work. I've changed that, and in the end, there's a link to my blog where I will shortly I will put up a post about getting that working. Why isn't this connecting? What? Hold on.
You're already connected.
I think, well, right. This is all, okay. So I'm just gonna connect this over a local network and that will work. Because I say it will. I want a shorter Ethernet cable. So anyways, it works on my home Wi-Fi and it's fun and yay. But here it's not working, so whatever. So for this, with this, let me just see, ifconfig. I actually need to reconfigure my adapter on my computer. But what we're going to do is we're going to SSH into the Galileo. So when you install that SD card image, you're manually, let's do 192.168.0.1 or 100/24. No router. What we're going to do is we're going to SSH into it. Let's see, does it have, where's wait, ifconfig ETH0 up, ifconfig W0 down, because it's, okay,
There you go.
it has an IP, or ifconfig ETH0 IP 2 or
You have /24 at the end of that.
it's complaining that IP is bad, or bad.
Oh, you read about the, yeah.
Okay. I haven't had to do this because it's worked before. Okay, now this should work. So now we're going to SSH into it. SSH root at 2.168.0.102. Yes. So now we're in here. So what we can do is we can do everything we could like we would there, but we can also use SCP. So I like using SCP to get files on and off. So if we look here, so actually if we look in ls/media, you'll see the real root. In real root, we'll see there's that folder we put there. So another way of getting things on it is with SCP. So I'm just going to open a new thing and see cd. So in here I have some files. So like for these, this is SCP is nice because I can just type in SCP root, or not that. I can do like SCP. Let's say the air quality one, air quality, and I can do root at 192.168.0.102 colon. That's the directory, and I'm just gonna say the home directory. This is nice because it's easy and it should work on most networks. I have all these files there, so now we're going to go and we're going to connect the Galileo to the internet, except the internet isn't working. So I'm going to pretend this works and explain what it should do, because it will work. So, have any of you heard of Matt Richardson's new book he's doing, Getting Started with Intel Galileo? Yeah, he just released it recently. This is it. It's a great book. I highly recommend you get it. This example is from his book. So what this does is, in this example, he put up this website, and if you go to the website /JSON, I'm going to try and wrap up quickly. It will return you a JSON thing. What you can do is he wrote a Python script that, not this one, the other one. Actually, I want this one. Or, wait, no. Yes, that one, blah. So all this does is it gets it and it prints how many days until the next issue of Make will arrive. Make Magazine's a magazine I really like, and this is a cool example. So for it, in this code, what it does is it uses the system command. I really wish I could make that go away. And the system command is the same as typing it in from the terminal on the Galileo. It always runs from the root directory though, so, and same for the file thing. So what I'm doing is I'm running that script. It will then echo that output to response.py, so that print days until next make thing, that is going in response.txt. Here I'm opening that file. So this is just a file object that's going to hold it. I open it in read mode. This copies the output from the file into output, which is a character buffer that's 5 long. Then down here, this ATOI function converts it from this character buffer to an integer. And then what would happen is if I were to connect the LCD to it, you will see everything on it will work except for the part with the internet. So I'm just going to show you how you'd hook that up. So on the LCD, hopefully remember which pins it goes on. You connect your ground. You can see that mostly. Your power. Ground is not that pin. Wait, yes it is. Power. These 4 pins go to 2, 3, 5, 4. We'll get this to work, mostly. White, yellow, black, or green, whatever. Yellow, green, and then 11 and 12. Should work because it did at home. But actually, wait, I might be able to get it to work that way. So now if I were to upload this code, what you'll see it do is, I'm not going to show the screen because it doesn't really matter. Can you see, now can you see the LCD? So it's going to do that. I'm going to see if I can set up my laptop to share the internet that it has, and if I can get it to work that way. If it
just update the script so it just doesn't connect to the baseline, it just dumping that. This is printing a number, right? So
yeah, actually, I could just do that. Or, I want it to work on the internet, though, so I'm going to get it to work. Even if it, well, probably not if it means me taking too long, but besides that. Start. Okay, now it should work. Let me just see. Okay, screen. Config. Still not working. Not working. Okay, so you know what? The network isn't working. I'm just gonna make the script be different. So on the Galileo, you don't have Nano, which is a common text editor people like to use. Instead, oh, wrong screen. Instead, you have Vi. Vi is like Nano, but it doesn't have the stuff at the bottom. So I'm just going to edit that file with Vi. In Vi, you have a few different things. What the hell? Okay, that file got screwed up. I don't care. If you press I, in the bottom left, you'll see that I there. Now you're in insert mode, so I can actually just change this whole thing here. And I can... Oh, that's where it is. The screen's too small. Actually, if you press DD, that will delete a line. So now I'm just going to go down. DD. No. Escape. I don't know. This isn't working. You know what? There's an easier way of doing this. Escape, :WQ will write and then quit. Echo, print, 50 to JSON parse.p. What? Oh, right. I need. Yeah, I know. I don't care. If the internet's not going to work, then I don't care if the file's overwritten. So now, if we go back to the computer and I reset the code, which will rerun it, it should run, and now it should say 50 there. And I say it will say 50, and it will say 50. If it says a 0, you are all wrong. But so now it works. So if the internet was working, this would work. We're pretty much out of time. I'm gonna work.
You got to a quarter after.
Oh, quarter after? Okay, then that means I have more time. I thought I had to end at 2 or 3. So yay. So for this, I've modified the code that I will show you, and what this will do is this actually uses what's called the pipe or something. It's called popen. And what this does is instead of opening a file, it opens the command as a file. So what I'm doing is I'm opening the next make advanced thing. If I cat that one, The only thing it does differently is I'm writing to a file the volume number. So now you can know the next edition of Make that's coming is going to happen in 50 days, which is actually about right because I checked last night. And it's volume 39. So for this, what it's doing is this is just printing that it's X days away. And then it's going to do this. It's going to say it's this many days away. And then this is one function called getDays. GetVolume will just check that text file, and it will do that. So what I'm going to do is I'm going to make this echo print print 50 next whatever. And so now it should work if I upload this version. Now you'll see, this screen is sort of hard. So now you'll see, so now there's the extra space. It'll say 50 days until Make 39 is here. And we can pretend that's right because the internet's broken. But so I actually wrote a script that, where's the script? Here's the script. That will use the AirNow API. It's an API that will tell you the air quality. Oh, yes, change the screen. Sadly, because we don't have internet, it doesn't work. But essentially what it does is it will go to the code. It will go to that website. I even made it sort of fancy. It has these values up here. It will then go to that website, get the data for both today, or now, and it will parse that. It'll get the air quality index, which is just the maximum value of like carbon monoxide, ozone, particles over 2.5 something in size or something. Essentially, this is like, it's the worst value. And I write that to the current AQI file, and then I do the same thing for the forecasted one. So if I open that code, I do pretty much the same thing. The API is rate limited, but it's pretty, no, not this one. It gives you 500 requests an hour, so I can check it every 10 seconds. I'm just going to actually change this. Actually, wait, no, that wouldn't work. I'm just going to comment out this line here so it never runs and the files don't change. But now if I were to upload this, when I upload it on the Galileo, we should see that the screen's still hard to see. See, does that? That's a little better. So now it will just 44 and 50. What I'm going to do is I'm going to, let's see. Okay, so I'm in the Galileo. I'm going to actually change the values of those files. I'm just going to echo whatever to them. So I'll show you that quickly while I do it. So if I cd to the root directory, you'll see there's these two files. If I change these, I can actually make this say pretty much whatever I want. So I'm going to do echo hi to, all right, that doesn't need quotes, current AQI, and then echo, let's have some fun, 25, the internet broke, that should fit, to forecasted AQI, and now, quickly switch over, next time this updates, it should say hi, and actually, it should work. Actually, wait, that might not work, but the second one might not work, but it's only a small buffer. It should update every 10 seconds, or I can just reset it and make it do that. Also, with the Galileo, to get the LCD working, there's an extra line of code you have to have. I'm going to get these examples online, like I keep saying I will. So, okay, this isn't working. The reason is, I think it's that it only has like a 5 large buffer. So yeah.
Characters, yeah.
Hopefully it's limiting to the last 5. I was planning for this demo to work. I'm really disappointed. But yeah, I'll take questions now, and we can turn on. Yeah, let's retry the Wi-Fi too, and I'll take questions. So, any questions?
Have you had any issues with your wireless card, Galileo?
So, for me, this is the only time I've had issues. I don't really know how to do much of the Wi-Fi stuff. I know you do like WPA passphrase.
No, what I was meaning is the stability of it. So the college is probably just they didn't enable IPv4, so you probably it's probably not nothing you did wrong.
Yeah, okay, yeah. Yeah.
Because I haven't purchased like a wireless.
Yeah. So with this, it's actually I'll check and verify. It's the Intel Centrino Wireless N135. If you go online, like on Amazon or something, I think you can get it for about $15 to $20. Actually, I have one other thing that there's a, if online, let's see, shopping, just how cheaply, so $21, you can get, this one's more advanced, here, is that the right one? Yeah, $15. If you go to maker.intel.com, it's a redirect and it's sort of slow, but they have a bunch of projects people have made. Earlier when I went there, they had this demo for controlling I/O on the Galileo with Wi-Fi. Because this is a whole wireless card, you can set it up as an access point, and I actually have the micro SD card for that. I haven't tried it, but it should work, so I'm going to try that. So to do that, all you do is you can just turn off your Galileo, you can press reboot, and when the LED here is off, you can do that, and then just unplug it, and disconnect this, and put in the other micro SD card. I'm hoping this might work. You'll see it might not work, but it should work. There should be, so all I did is I just changed the micro SD card. And now the redirect isn't working. Sometimes the redirect I found, it doesn't work. I think it's because they're changing the website. Let me try it. Intel Galileo I/O. No, control, and I'm trying to remember what would it be called, GitHub. Okay, here it is. It's the connect anything thing. Let's see, there's this thingy I have to download too. But anyways, what this does, it creates a Wi-Fi network called Connect Anything. If you go to this web page, it then will let you control the I/O on the Galileo with it. I'm actually hoping this will work, even though I haven't tried it, which probably means the demo gods won't let it work. There's also code you have to upload to the Galileo. I'm just gonna pray this works, and probably it won't. But yeah. Oh, are there any other questions?
So is this like open source like board design?
It's all open source hardware, all open source software. You can, so with it, you can actually get the, you can go and download the design files there. They used Allegro for it. The problem is it's a 6-layer board, so something like EagleCAD wouldn't really work, or it would work, but you have to pay money. And because the routing is one of those things, they need a more professional design tool. So you need Allegro. You can get like a trial version of it. Yeah, but the schematics are all available as a PDF too. I'm gonna see. Oh yay, this broke. Let's see. Okay, so I'm hoping that ls/media.
Where do you buy the board itself?
The board you can buy from Mouser. I actually have a slide for that. Hold on. Yes, Fry's Electronics sells it. They were sold out a little bit back when I checked last, but they do sell it. Mouser, Adafruit, Maker Shed, Spark Fun sell it.
On Amazon.
Yeah, Amazon sells it. Newegg.
What price range are they?
I believe it's around $60. Sometimes you'll see it for more, but you should be able to get it for about $60. Other good places to get hardware are Adafruit, which is on the other page. Evil Mad Scientist, they have some cool like LED products and things like that. Maker Shed, Radio Shack, Fry's Electronics again. One other thing, if you're playing around with the Galileo and you get an error like this, if we look in here, it'll essentially say whatever, this error you can ignore. In/media, there needs to be a file called real root, or it will give you an error. An easy way to fix that is just to make their, their/media/media. That should work. And now if I reboot, it should work, or I'm just gonna unplug it and plug it back in. Though I hope that wasn't, at home I had a bad SD card, and I hope this one isn't it. But yeah, please boot. It should work. But yeah, are there any other questions?
Talking about the firmware update?
Yes, okay, yes?
So yeah, you talked about the availability of the board. What about sourcing SoC?
If we go to Mouser, they actually sell it. You can get it. I'm trying to remember how much it costs. It's called the Quark X1000 SoC. Let's see, Intel. You can get it on Mouser. Let's see, for about $15. So, or wait, which one is there? Are a few slightly different versions, I think. So on Mouser, you can get the Galileo for $67, so I'm slightly off. Trying to see, but anyways, let's look at this. So you can get the Quark processor, the Quark X1000. This is it, SoC. You can get the design files online, so you can make your own IoT. So Quark is, it doesn't have graphics. It's 400 megahertz. It's designed for IoT type things. So you could put this, if you saw the IoT talk this morning, the presenter didn't show up, so we just sort of talked about IoT. The Quark could be a great thing for some of the more smarter IoT devices. So like a vending machine, and it also does payment processing as well as things like that.
Is this like x86?
It's Pentium instruction set compatible.
Okay,
It doesn't have any SSE.
What?
It doesn't have any of the SSE extensions like for graphics.
It doesn't have graphics.
It have to be like recompiled, I guess. Like.
Yeah, it's not really recompiled. If you download something from source, you have to compile it. There's also, the Yocto project source for the SD card thing, that's online. If you go to malinov.com/all that stuff, I'll put a link to it on my blog, I hope. It talks all about how to rebuild the image. You download it, you do this stuff, you wait a few hours, and then it's done. You're building a whole Linux distro, so it takes sort of a long time. And also, the path, like how long the file names are, you should probably shorten the names of the folders like that contain it before you actually build it, or else you can get issues with it taking too long. So like, I renamed MetaClanton to like Clanton, and the containing folder just Quark. If you don't, you'll get an error that seems like there's something wrong with the code. It's actually that the path's too long and like a Stack Overflow or something. Any other questions? Yes?
A comment. I was at Windows Build conference this week, and they actually showed Windows Embedded running on Quark.
Yes, so that I don't really know much about it. I didn't get to go to it. If you can get me to go, get me a ticket, that'd be great. But let's see. So apparently that demo thing I had isn't gonna work. I think that's a bad SD card. But so I don't know anything about what they're doing. What I do know is that it appears to be full Windows. It also, I think it's going to be really cool if they make it available and it works well. I'd love to play with it. They need to release it though. Any other questions?
The thing is, they're going to, for all versions of Windows less than 9-inch displays.
Yeah, I saw that.
It'll be free, so you'll be able to run embedded Windows on the thing.
Yeah.
What LCD did you have?
This is just a 20x4 character LCD. You can get this from Adafruit sells it, SparkFun sells it. I think Maker Shed might sell it. I don't know. Just go to if you go to Adafruit and you search for LCD. Yeah, it doesn't have a model number on it.
24 inch.
20x4, so it's 20 characters wide, 4 down.
Okay.
Yeah,
The serial version, not the parallel version.
yeah. No, this is the parallel version. SparkFun, I know, sells a serial one. Adafruit might sell a serial one. Serial needs 1 or 2 I/O pins. Parallel needs more. I'm gonna need to be done now, so you can talk to me later. Thank you.
Are you going to make